Let's do one more factoring example before we leave this, and I'd like to look at one where the lead coefficient, that a value that I talked about before, is not equal to 1. So let's look at this one. 2x squared minus x minus 3. Again, I'm keeping these with reasonably small numbers just for the purpose of demonstration. So again, I'm going to try to work with my rectangular region. This time, the numbers that I'm looking for in the top are the a times c, which in this case is 2 times negative 3. That's negative 6. And on the bottom, I have negative x. Well, what that really means is negative 1 times x, and so in the bottom goes the number negative 1. What I'm searching for now are two numbers whose product is negative 6 and whose sum is negative 1. So again, because this sum is negative, I know the larger of the two, absolute value-wise, the larger of the two factors of negative 6 is the negative number. So it could be negative 6 times 1, or it could be negative 3 times 2. And notice negative 3 plus 2 is equal to negative 1. So that's the pair of numbers that I'm going to use in this case. Back to my quadratic, I'm going to write now, instead of 3 terms over here, I'm going to write 4 because I'm going to break the middle term into 2. So my 4 entries into the area region are 2x squared minus 3x, which came from here, 2x, which came from here, and notice that these two add up to negative x, and finally negative 3. I'm now ready to look for my greatest common factors across the rows and down the columns. Here I have a common factor of of x, and so this must be 2x, which means this must be 1, which means, from using this row again, x times negative 3 is negative 3x, and I do my check again. Negative 3 times 1 is negative 3, so it appears that this is the correct factoring. That factoring is x plus 1 and 2x minus 3. I'm sure you know that when you multiply, order doesn't matter, so I could have written that as 2x minus 3 times x plus 1.